In this video, we're going to now provide the implementation to the bind method for my monad state TSM. Okay, so this is a code that we just started off in the last video. We had some boilerplate Haskell code there saying that the constraint on M is that M needs to be a monad, and I was making state TSM an instance of the monad's type class. And what we did in the last video was to provide the implementation to the return method. And the return method has the following type signature. It takes in some value of type A, and it gives you back some value of type state TSMA. And the implementation were as follows. I had X over here, some variable X that contained a value that were to be of type A, and it would give you back as a return some value of type state TSMA. And one of the interesting questions, or at least I felt interesting when I was learning Haskell, I would always think from this point of view, how would I even go about creating a value that were to be of this type state TSMA. Now, I already know from my new type definition here where I have this wrapper that has wrapped this entire method here, and I know that if I were to invoke the value constructor state t, if I were to invoke this value constructor state t, and if I can somehow pass in the appropriate and the right and the correct value of this type here, I can then create a value of state TSMA. And that's exactly what I did here. This is my value constructor. This is my value constructor that is getting invoked here. I'm then passing in some value that belongs to that type signature there. So S is my state here. S is some state here. And this is this function. This is a function here that takes in as a first parameter some state S here, and then it gives you back some monadic value. And this monadic value over here, I know it's a monadic value because I'm invoking this this return statement here, and this return statement here is the implementation to whatever monad M refers to. Okay, this return statement is nothing to do with this return statement here, because this one in yellow, this return statement over here is the implementation. It's the implementation to the monad state TSM. Okay, this is the implementation to the monad state TSM. The return that I'm invoking here is for the inner monad, is for the monad M, and whatever M refers to is that implementation that gets invoked. Okay, so with that recap, now let's go ahead and provide the implementation to my bind method. So what I'm going to do first is I'm just going to rewrite the bind method. So again, let me just use maybe pink for my types here. That's what I had in the last video. So for the bind method, the type that I can get from the monad's type class is that the first parameter is the monadic value M of A, and then I have a function that takes the pure value A devoid of the monad, and then gives you back this monadic value MB, and the function, the bind method, in turn gives you back this monadic value M of some value of type MB. Now what I'm going to do is I'm just going to rewrite wherever I see M with my state T as M. So M is over here as state T as M, A, and again my function A, and this M would rewrite this as state T as M, and then finally this MB, I'm just going to again rewrite this M as my state T as M, state T as M, and the B as it is. Okay, so let's see if I can actually provide the implementation here. So the bind method takes in two parameters. It takes in this first parameter, and then takes in the second parameter, which is a function. Okay, so let's do this. Let's call this let's have a value of type state TSMA. Let's just have it maybe in let's just do this way. Let's just say TM is some variable that holds a value. It holds a value of type state TSMA, and then I'm just going to use my infix notation here to provide the implementation to the bind method. And the second parameter is just some function f here. Okay, so let's just say f, and this is going to be equal to, and here's where I'm going to provide the actual implementation. So again, remember tm has some value of this type state tsma, and f, my function f here, has some value of the following type there. This entire thing is going to be equal to some value of type state tsmb. How do I create a value of type state tsmb? Again, let's just use a value constructor. Okay, this is the actual new type definition there. And again, if you're just want to make things a little bit more cleaner, a little bit more neater, you can think of this a, instead of writing this a there, let's just make this as b here. Let's make that as a b, and let's make this a as a b. Okay, so in order to create some value of type state tsmb, which is right there, state tsmb, I must invoke the value constructor state t. And by invoking the value constructor state t, I must pass in some value that has this correct type signature. Okay, so this is going to be equal to, let's just invoke a state, a value constructor, which is state t, and and uh, again, keep this high level picture in mind here. What I really need to do is I need to pass in some value in this green blocks. Okay, so think of this green box as containing some value that has a type. It has a type of the following kind here. Okay, if this green box has some value of this type there, then I know that this entire thing, starting from this point, right there from the value constructor and ending at this curly braces, this entire thing over here is going to have some value of type state t s m b. Okay, and that's what I'm trying to get at. I'm trying to provide an implementation here so that when it takes in these two parameters, tm and f, I can give back as an output some value that matches the type signature, this type signature there. Okay, so with that intuition, at least with that high level intuition out of the place here, uh, let's just fill that green box now. Let me just erase these things here so that I have some space to write. And now what I'm going to do is I'm going to provide that implementation here. Okay, so what I know right now is that this value tm, or this variable here tm, has some value. It has some value of type state tsma. Now what I can do is, if I were to invoke the accessor run state t on some value of type state tsma, I'm going to get back as an output this following function. Okay, let's just do that. Let's go ahead with that flow first. So I'm going to say at this point, I'm just going to say this entire state t dollar and my curly parenthesis, and I'm going to say just going to complete first part here, that this entire thing is going to be a function, that takes in some state s, and what I need to pass in now is some it's going to give back this function that takes in the first parameter as s, is going to give you back as an output some monadic value. Okay, so the way I'm going to do this is because I'm dealing with because I'm going to deal now with tm, and tm is some monadic value. Okay, and tm, because tm is some kind of a monadic value which is of this type state tsma, I can use my do block. Here. Okay, I'm just going to use do block here, and I'm just going to run my accessor. Run state t. I'm going to run my accessor run state t on tm. I'm going to run it on tm, and when I run it on tm, what's going to happen? When I run it on tm, this entire piece is tm, I'm going to get back a function. This entire piece in blue is going to have a type. It's going to have a type of the following kind. Okay, so run state t on tm is some value of this type signature. Now because this is a function, because this is a function here, what I'm going to do is I'm going to take the state s, what I have here, I'm going to apply that on this function. I'm just going to apply that on that function because the function takes in this s. I'm passing in that parameter s, and this entire thing now, this entire piece now is going to contain a value, it's going to contain a monadic value of the type m. Again, let me not use yellow here, let me just use green here. Okay, so this is going to have some value of the type the following kind here. Okay, so again, just keep this in mind. Run state t, when it takes in the parameter tm, okay, run state t right there, when it takes in a parameter of the type state t SMA, I know that tm right there is some value of type state t SMA, is going to give you back as an output some function, which is this piece right there. On that function, I'm now passing in my state s from this piece here. When I pass in the state s here, this in turn gives me a monadic value of the type m of a comma s, where a comma s is wrapped in a tuple. This entire piece here, which is this entire piece in green, is a monadic value, and on that monadic value, what I'm going to do is I'm going to tear apart the monad out. I'm just going to take the monad out so that I can just play with the actual tuple. Okay, and this is I'm using this using everything in my do block, and this is going to give you back some value of the kind b comma, let's call this s1, the new state. Okay, so I got rid of this monad m, and now I've got back some value of this type there, a comma s, which is this tuple right there. On this tuple, which I just extracted, b comma s1, I can now simply take this tuple. I can simply take this tuple here, and I can say I can take my function f, which is at this point here. Again, just so that just from a clarity point of view, let's not use the variable b. Let's just use a there. Just use a there. Okay, it's just a variable a, which just contains some value of this type right there. Okay, so I'm just trying to be a little bit consistent there. Okay, so this is just my variable a, just contains some value, and that value happens to be of this type a in this type signature. Okay, now I have the second parameter. My function f. What does this parameter function f do? This parameter, the function f, is a function that consumes some value of type a. Let's do that. Let's just now just take this function f. Okay, so let me just take my function f here. Okay, let's take the function f. I'm going to take my function f now, and on that function f, I'm going to pass in this value a. Okay, so f of a. What does f of a give you back? If I take this function f, and on that function f, I pass in this value a, I'm going to get back some value of type state t smb. Okay, this is going to be some value of type state t smb. Okay, I could, if we still want to go, I mean, there's a shortcut at this point here. But what I can do is I can say, all right, let's do this. Let's just take this, which has a type. This entire thing over here has a type of state t s m b. Okay, fa has a type there. On that fa, if I run the accessor run state t of on the entire thing, if I run the accessor run state t, consumes a value of type state t sma. I'm passing in that value over here, f of a. This in turn is going to give you back this function. This is going to give you back this function, of which is this entire piece here. This entire piece comes back out as an output. Okay, so if I take this run state t f of a, okay, and on this piece, which is this function, I then pass in this new state s1. new state S1, I'm going to get back this monadic value. Okay, I'm going to get back this monadic value. On that monadic value, using my do block, if I separate out the monad out, if I just separate the monad out, I'm going to get back these new values, which is going to be, let's call this variable b, and let's call this variable s2. Okay, so b is my value and the new state in this case is s2. So I got my B, I got my new state value S2, and then all I need to do at this point is just complete the original value constructor that I started with. So at this point, I can simply provide M of B comma S. So I can say return. Don't have enough space there, but I'm just going to say return B comma S2. Okay. And by saying b comma s2, I have provided the implementation to the bind method. Now I know things are a little bit confusing here because I'm trying to give you I'm writing some Haskell code here, and at the same time I'm providing my type signatures here so that you follow along as to what are these intermediate types that are getting generated as I write my code. But what I'm going to do is just for clarity purposes, let's just rewrite just the Haskell code here. So just rewriting just the Haskell code at this point again. So this is equal to state t, okay, and then I have my do block at this point, and I'm saying run state t on tm, and then I passed in my state variable s, which generated this tuple of a comma the new state s1, at which point I could then do run state again on fa, and then I passed in s1, and this generated for me b comma s2, and then finally I had over here. You might notice some redundancy that I have at this point, and I'm going to point out that redundancy in just a second. So the first point is just to show you the clarity, or at least the intuition as to why this code is the way it is here. Okay, so this is the actual implementation to the bind method here. But what I can do is I can actually just get rid of this piece here. I can just get rid of this piece here. So I can get rid of this piece at this point here, because all I'm doing is whatever is run state t of f of a. So I know that the type for this entire piece in green, the type for this entire piece in green is this function that has the following kind here: s of m of b comma s. Okay, and on that, when I provide in the state s1, this entire piece in green, including S1, now has a type. It has a type of the following monadic value. Okay, and all I needed here in my value constructor was state t. State t takes in this S. Okay, I have that S right there, followed by giving me back as an output this monadic value, and the entire monadic value is in this entire piece there. So again, it's the same thing. I just striped out this yellow piece of the code here, which was kind of redundant. It wasn't required, and I can just have it by saying run state t on f of a, and then passing in the state variable s1, because this entire piece over here generates back to you some value of this kind, of this type monadic value. And what I was doing previously was then again tearing apart that monadic value by getting the actual tuple and then rewrapping that tuple in minimal context by calling the return again. So I just got rid of that redundant code there, and what we have now is the actual implementation to the bind method in for using the state transformers. Now, in my last video, I'm just going to take my state transformer and I'm going to make it an instance of the of the monad trans class.